Hey everyone, I hope you're doing well, and today we're going to talk about not just what the Pythagorean Theorem is, because we kind of did that last lesson, but now we're going to practice it, and we're also going to talk about these things called Pythagorean triples. So again, let's remember that the Pythagorean Theorem only applies to right triangles, so it has to have a right angle in it, and it's a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. The hypotenuse is just the side across from the right angle. So now I want to touch on something called Pythagorean triples. So these are just a group of three numbers that satisfy the Pythagorean theorem. And what can happen is if you know these triples, it can help you solve triangles much quicker. This is really helpful for things like standardized testing like the SAT, ACT, and just problems in class. Your teacher will often use these common Pythagorean triples, and you could look really smart and impressive if you just knew them right off the bat and you could do them without doing any work. Your teacher might not even be able to do them that fast. So let me show you how they work. So it's a group of three numbers that satisfy the Pythagorean theorem. So what I can do is I can draw a triangle, and what I'm saying is that these three numbers will satisfy the theorem, a squared plus b squared equals c squared. So let's just pretend this is a right angle, bad triangle again. So 3, 4, 5. Now, common question is, how do I know which side is the hypotenuse and which are the legs? Well, the largest one always has to be the hypotenuse. So that means that this would be 5, and that the legs, it doesn't matter the order of them, would be 4 and 3. Didn't draw that to scale, but it'll be okay. And now what I'm saying is that if this is a triple, then it should work. So 3 squared plus 4 squared, not 14, just 4 squared, should equal 5 squared. Let's see if it's true. 3 squared is 9, 4 squared is 16, and that equals 5 squared is 25. That is true, so that's a Pythagorean triple. So hopefully you see how that works. Let me show you another example. Let's do the 5, 12, 13, which is another common Pythagorean triple. So what you can do when you know these is that when you're given two sides, say you were given sides 3 and 4, without even doing the math, you could say, oh, well, the diagonal is going to be 5. The hypotenuse is going to be 5 because it's a triple. So let me write this here. We have the legs are 5 squared plus 12 squared, and we're trying to see if that equals 13 squared. Well, 5 squared is 25, 12 squared is 144, 13 squared is 169, and 25 plus 144 is 169. So 169 does equal 169, so that's another Pythagorean triple. So as you can see, you can kind of just do the work quicker if you know the triples. They're actually really cool, so it's fast and it's easy to use. And an important thing here is that all the Pythagorean triples will remain Pythagorean triples when you multiply them by some constant. So that first triple, 3, 4, 5, if I multiply everything by 3, that means I would get 9, because that's 3 times 3, 12, 4 times 3, and then 15, 5 times 3. That is also going to be a Pythagorean triple. So let me show you what I could do. If I was given a triangle here, and I saw that the hypotenuse was 15, and my leg was 9, I could say, without doing math, I could say, I think that's a triple. And then I could divide the sides by 3, and I would get, well, 15 divided by 3 is 5. 9 divided by 3 is 3. That looks like this Pythagorean triple, so the other side's got to be 4, but then I multiplied everything by 3, so it's got to be 12. So that side would be 12, and that's another Pythagorean triple. 9, 12, 15. So another example that I wrote down, 10, 24, 26 will also be a Pythagorean triple because it is the 5, 12, 13 triple with everything multiplied by 2. So I know this might be confusing right now. Let's just get into some practice and see how that works. So let's just solve this using the Pythagorean theorem. So again, I'm going to write out what it is. It's a squared plus b squared equals c squared. I see right away that there is a way to solve this just using a triple without doing any math. So if you notice that, try to do it and then check your work by actually solving the theorem. So it is a triple. So a squared, we can make that the 6 because we know that that's one of the legs. We'll be solving for b, but we'll make that x squared because we know that x is equal to b. And then 10 squared is c squared, and that's 100. I'll just write 10 squared for now. And then now I'll square everything. So 36 plus x squared equals 100. I'm going to subtract 36 from both sides. I'm going to get x squared equals 64. And the square root of 64 to get x by itself, x equals 8. So That is a Pythagorean triple. I just did that circle really bad. So the Pythagorean triple would be the 6, 8, 10 triple. And what they've done is they've taken our 3, 4, 5, and instead of multiplying it by 3 like I was talking about, they multiplied everything by 2, and it remained a Pythagorean triple. So hopefully that makes more sense of how that works. Let's look at another example. So we have 2, 12, and then x. So again, we got to solve using the Pythagorean triple theorem. This time you can't use the Pythagorean triple. This isn't one of the well-known ones. So again, I'm going to write down my theorem just so it gets ingrained in my head. I want to know it inside and out. Obviously, my hypotenuse is across from the right angle, and that is the 12 in this case. So I've got 12 squared, and then again, I'll just set the 2 equal to the a. It doesn't matter if I do a or b. Plus x squared. I'm solving for that last side length. So I get 4 plus x squared equals 144. Then I'm going to subtract 4 from both sides. I'm going to get x squared equals 140. Square root both sides. I'll get x equals the square root of 140. And now, just so you guys are aware, sometimes your teacher will want you to simplify these. So if we have 140, the way you get rid of the, we don't want something so big under the radical. We want to simplify it if we can. So what I do is something called factor trees. You can look at this up online if you want more information, but what you do is you figure out numbers that can multiply into 140. The one I see easiest is 10 and 14. And you just go all the way down until you get to numbers that can't be factored anymore. So what can be multiplied into 10? Well, that's 5 and 2. What can be multiplied into 14? Well, that's 2 and 7. And then what you do is if you have 2 of the same number, you can circle them and take one of them out. So I've got 2 2's, so I can cross them out and bring one on the outside. So x equals 2 times the square root. Then on the inside, I would have 7 times 5. Because they're still there, I wasn't able to take them out. But I can simplify that, obviously, to 2 times the square root of 35. So that would be the simplified version of the square root of 140. Just ask your teacher if they want you to do that. Some do, some don't. So hopefully this makes sense. Hopefully now you've gotten more practice solving the Pythagorean theorem. You know these things called Pythagorean triples. I would write these down, study them, because they really do make the problems go so much faster, and you can impress your other classmates as well. So thanks for watching. Let me know if you have any questions.